How's it going, everybody? Yeah, my name is Matt Walters, and my online moniker is MateoDelNorte. You might be wondering why in the world I'm MateoDelNorte, since I live in New York. Can't get much further than that in the United States, but I spent a short amount of time living in South America. So when you're on the other side of the globe, you become MateoDelNorte. Yeah, can you guys see my screen? It should be shared.
We can see it.
Cool. All right. So this is going to be, and is it too loud in here, by the way? Do I need to shush anybody? Cool. Awesome.
I can hear you.
Cool. So yeah, this is going to be a little bit of an Node.js presentation. And I called it Deep Dive on purpose. What we're going to do is spend a little bit of time first kind of talking about what Node is, and maybe a little bit of context and the history of Node and why it was created to begin with, and the problem it was intended to solve. Then we're going to kind of go back in time and look at some magic original commits and try and put ourselves in the mind of the original creators, and give us sort of like the angle. So behind the context of why was Node created, like what were the thought processes and what guided them to make this thing? Because it turns out that some of those original thought processes followed Node as a project all the way through, and I think are a big contributor to some of its successes today. So anyway, without further ado, let's dive in to the deep dive. So who dat MateoDelNorte? We'll start just with the history of my life as it pertains to Node.js. So there's a picture of me over when I started a company and went through Techstars. And while I was in that process, on like day 3, I decided to use Node.js. It was super early days. I think it was like 0.4.7. And I wanted to see if I could make a simple little system of distributed services using AMQP. And bam, I could do it much faster than using any tools that I had worked with before. So I was hooked. We ended up moving that company to New York, and I got involved in the Node.js meetup. Ended up growing that from a small number of people to a large number of people, and holding a bunch of conferences and working for companies and consulting at the same time, building everything from high-tech touch treadmills. This is actually the one that that my software runs on over here. That all runs on Node.js, to corporate bond exchanges. I don't know how to take a picture of a corporate bond exchange, but that's the best I can do. So that also ran on Node.js plus some C++ for some performant parts. And all that led me to here. So that's who dat MateoDelNorte is. So here's our agenda for the talk today. We're going to talk about what is Node.js. We're going to put on a snorkel, and we're going to dive in deep. And once we get there and we have our sort of frame of reference, we're going to talk about what Node consists of. We're going to come back and sort of iterate on that original question of what is Node.js. And we're going to try and take all these disparate thoughts that we have and pull them in together to a kind of a unified concept. And then I'm thinking we'll probably reach enlightenment. Not 100% sure we'll get there, but we're aiming for enlightenment. So here we go. What is Node.js? I'm about to tell you the same thing about 3 or 4 times, but in a different way. Here we go. This is the text that I just ripped right off of the Node.js website. So this is the easiest one to have already read. Node's a JavaScript runtime built on Chrome's V8. It uses event-driven, non-blocking I/O in order to make it lightweight and efficient. Node's package ecosystem, run by NPM, is the largest ecosystem of open source libraries in the world. So there's some cool stuff in there. One's impressive, that there's the largest amount of open source reusable modules compared to any other platform. That means probably if you want to use some stuff, it's out there. It's using Chrome's V8. So they're dogfooding other projects instead of trying to reinvent the world. And one of the big driving forces behind it is to make sure that it's event-driven and non-blocking. All right, let's keep rolling. So Node's a software development platform that promotes evented asynchronous programming patterns via a fancy stack of async libraries that expose a single JavaScript interface upon which you run your code. Okay, so there's a bunch of libraries that are all hidden away, sitting underneath this one interface that's shown to you, which is JavaScript. All right. It's a software development platform that hides away the fact that it uses threads under the hood for I/O, whether that's for the file system or for network calls or any other type of I/O. And it hides that stuff away by only exposing a JavaScript runtime and an event loop to you. Oh, but there's also a C++ and C binary add-on interface, just for fun. And we'll learn more about what that is later. Node's pretty rad because usually someone else has already made whatever it is that you need, and if they haven't, then you can usually, oh, 1 second, sorry, I'm gonna silence my phone, it's ringing in my ear. And if they haven't, you can usually find it on GitHub, or at least something that's close, and fork it. And if that doesn't work, you can just build it. But the first thing you do is probably going to be finding some awesome name on NPM and grabbing it and then hodling that forever, which everyone does, including me. And you can see the proof because I have dance.js and I still haven't submitted anything to it. So the final description of what Node is it's the result of a guy named Ryan Dahl's attempts to make a completely asynchronous, event-oriented library for writing networked applications. When confronted with what language to slap on top of it, he picked ugly little JavaScript because it turns out JavaScript is asynchronous and event-oriented too. So that's what Node is. Are we ready to put on a snorkel and dive deep? Let's do it.
Yay.
Whoa. Beep, boop, beep, boop, beep, boop, beep, boop. Cool. So to start, we just dove into the Node REPL. So Node has a REPL. Node is, JavaScript traditionally has been, at least historically, a interpreted language. And it was the advent of the V8 JavaScript engine that made that not necessarily the case anymore. We'll learn more about this as we go, but it turns out that V8 made JavaScript both a interpreted and compiled language because it has in it a just-in-time compiler. So when Node is evaluating JavaScript variables, statements, etc., what it's actually doing is leveraging a very sophisticated C++ API for defining new types in real time to represent your functions, your objects, etc. And then it basically maintains pointers and references between things in the JavaScript space and what's going on behind the scenes in C++. And that's really the brilliance of V8. And that's what made Chrome fast. And that's what enabled pretty much the entire Web 2.0 revolution, allowing us to have fast-running, single-page JavaScript apps. And it turns out that V8, the engine itself, is just a reusable component that was used in Chrome. And you can kind of take it out and divorce it from the browser and end up using that for whatever purpose you want. And what we'll see in a bit is that Ryan Dahl had the idea of taking this thing that via a C++ interface allowed you to instantiate any sort of object, function type, et cetera, in JavaScript. You could use that to power something other than a browser, and in this case, networked applications. So we're looking at our...
Matt, can you quickly, like, ELI5, the just-in-time compiler idea, like, interpreted and compiled? That sounds great.
Yeah, so basically, and we'll get to this in a little bit.
Okay, if it's in the presentation, like, don't let me throw it off. But.
Yep. So we'll get to that when we dive deep into V8.
Awesome.
So we're looking at the REPL here. So it's nice that JavaScript is both interpreted and compiled, which we'll come back to describe more of later, because it allows us to use a REPL. And REPL stands for read eval print loop, which is just an application where you can type your code in, and as soon as you type it, the runtime will evaluate it. And it makes it especially nice for prototyping, very simple code, troubleshooting really inane issues and things like that. And you can start to kind of like glean some information about exactly how JavaScript and V8 works by looking at the statements here. When we execute a line, as you can see with the first line, it says undefined after it. And that's because it's actually evaluating every single line. And undefined is actually what's returned from that statement. There's no function there returning a number or a string or a value, so it returns undefined. And in JavaScript, we have two null values. One is null, and one is undefined. They're not equivalent, but they both kind of mean null. Undefined means that literally a property does not exist on an object. And in this case, where it says undefined, pretty sure what that's saying is that that this is not creating an object on the global namespace. Something that you'll see in the next couple of slides is that you're always within a function scope within JavaScript. And if you've just started your application, you're in the function scope, which is global. And there's always going to be an object related that's available to you, which is the global context. If you type global, you'll have access to it. Otherwise, any of its properties can be called by their name. So for instance, buffers, promises, anything that you can just say like new uint array, new array, stuff like that. Those are all properties on the global object, and you don't need to type global to get to them. You can just type them. So console is another object that is actually a property on the global object. And so you can just say console.log. And here you can see what everybody knows JavaScript can do, which is call a function and return the value. Cool. So you can also I
have a question. Sorry. So is the global object a function?
The global object, I don't think it's a function. I think it's just, well, so that's a, I don't think it's a function.
You said it's all function scoped. Okay, but never mind. Sorry.
Yeah, so there probably is a function. I don't think it's global. I don't think global itself is a function. But just to kind of dive in, there are ways to kind of call functions in a sort of meta way, which is like function.call or function.apply. And when you're doing those types of instantiations or executions of a function, you can assign the context. It's the first property that you call to function.call or function.apply. And so my bet is that they just call an empty function, which starts your application, and they pass global as the context variable to it. Does that make sense?
Yeah, that does make sense. Thanks.
That's what I would bet. I would have to actually go back and look at the source code. That's a really good question, and I should probably know that. Cool. So here's just another version of the same thing we just looked at with a little bit of extra information. And what's interesting about it is that we defined our function, and then instead of executing the function, we just console logged it. And we said it says function there. And a lot of people ask the question, well, does JavaScript have types? So JavaScript actually does have types. It just doesn't have a lot of types. So there are types such as function, object, array, string, int, like uint, and a few things, and those are all defined in the global scope. It does not have great number support. There's only one number. And there's historical reasons for that. Apparently, they were rushed in the creation of the language and just kind of didn't have time to implement a bunch of numbers, and so they picked float. And there you go, you get floats. So yeah, so this is really the extra thing that I wanted you guys to glean from this slide, that there actually are some types, and there are some interesting operators in JavaScript that you can use to determine what the type of an object is. One is type of. There's one called instance of. There's weirdness in the language where you can't. Where if you do type of and you do type of for an instance of an array, it will actually say object, because it turns out that arrays are objects because of their prototypical inheritance. So if you want to see if something is an array, you have to say instance of array, funny things like that. But anyway, the point of this is just to give you the point of reference, the frame of reference, that there are types in JavaScript. It's just not a strongly typed language, and there are not many types. Okay. So here's that global object, the global variable that I was mentioning to you all. And it's pretty much always available to you. And you can see that there are a bunch of different things in here that you may have used in the past that you just expect to be global and available to you. And you may or may not have wondered where they come from, but this is where they come from. They're all implemented on this global variable. And in a little bit, I'm just asking you to make a mental note. Remember that we're seeing this global variable and all these things are on it. And if you wonder, how do these things get on this global variable, we'll get there. Okay, so we can see that there is this thing called promise. So I wonder, if we go back a slide, if we do something kind of like how we did a console log of this function.toString, it was neat how it actually printed out the string. This is something I like to do sometimes. I'll hop in the REPL and I'll look at someone else's code that I'm integrating with. And if I don't feel like looking up their documentation, I'll just console log their function.toString and I'll read it in the console. And then I'll just type my code out to see if it works. And then I'll go put that in a unit test. So it's kind of nice built-in documentation for people who like to read code. I wonder what happens when we do that for promise. Let's see. That doesn't look like the definition of what's going on inside the promise function to me. Wonder what that is. That's weird. All right. We'll get back to that. So in Node, if you guys have used it before, or if you all have used it before, one of the great things about Node is module reuse. There's very good modularization of Node, even for Node core. use a require function to bring in other modules and use them within the module that you're currently coding and creating. So maybe we can at least use this technique of printing out the toString of a function on one of those. So let's take a look at FS. FS is the file system module. It has a bunch of nice methods for helping you use the file system. And fsync is a super low-level one of those functions. So this is what happens when you call fsync.toString. It's kind of nice. You can explore the Node API this way. But when we read it, fsync, if you're familiar with it, is a pretty low-level operation, at least from the Unix definition of it. This doesn't look like it's really doing a lot. I'm kind of wondering, like, what's happening at the end there? It looks like they've kind of like put some boilerplate cruft here, but really not a lot's happening. And then there's this binding.fsync that looks like it's just kind of like passing on all the difficulty of this function to this. So anyway, let's see what this is. So one of the great things about Node is that it's all open source, and you can just go to GitHub, the Node.js org, and hop over to Node and check stuff out. So if we go down to fsync, we're now looking at our function right here, and it looks exactly like we saw it, just with better formatting. And sure enough, it's exposing this function called fsync, and it takes, so first off, FS stands for file system. I'm going to guess that FD means file descriptor. And there's a callback. That's pretty normal for Node because calls are asynchronous. So we're making this FS request wrap, and then like we're going to make a callback when this thing is complete, and then we call this binding.fsync. So it seems pretty obvious to me that this binding thing is allowing us to get access to more behavior. So let's see what that is. So okay, this isn't going to help us out very much because it looks like there's a lot of usages of binding, but let's see where it gets instantiated. Okay. So now we're at this binding equals process.binding. So this process.binding thing is going to give us access to more code that's going to tell us what's happening. So, okay, let's see if we can figure out what process.binding is. First, so it's on process. And if we go to the Node APIs, we'll just go to the docs. We'll go to the newest one because that's going to be the most up to date. I happen to know that there is a process module. And process has a bunch of stuff for accessing things that are global, in particular to a process. And so it has things like the event args and stuff like that. Cool. So let's see if there's any mention of process.binding. Nope. Okay. All right. Weird. Let's see if there's nothing for binding. Okay. So what is this binding thing? Let's just go to the old faithful. Process.binding. Okay, we've got a few different answers here. I happen to know that this is the most succinct. So it turns out other people have wondered this ever since 2010. What exactly is process.binding? Process.binding is a static type map defined in source node CC that provides glue between C++ and JS code. It's meant for Node.js core modules only, like FS and buffer, not third-party extensions. Those other ones can be loaded with a simple require and module name without the .node suffix. Okay. So this is really loaded. It tells us a bunch of things. One, it tells us Node.js is both C++ and JavaScript. That probably blew some people's minds somewhere in the world when they first heard that. Guessing everybody here already knew. And it tells us that this binding thing allows them to import Node core modules that are C++ within JavaScript. So when we looked at this over here, and it said process.binding FS, what it did was it brought in the FS C++ bindings into JavaScript for usage within the JavaScript portion of Node.js. But let's go a little bit further. We're going to backtrack and then come back to what I just said. So they said that it's defined in node.cc. So let's go track that down. So node.cc, cool, here we are. Process.binding. Okay, there's some stuff in here. Binding. Okay, so there's the definition of the function. That looks pretty cool. If we kind of glance through this, it looks like it's sort of like getting a module and putting it into a module cache and then setting this exports thing. And if you've used Node.js before, and written a module, you probably know that you write module.exports or you write exports, either one, to signify that you are exposing some behavior, some functions, some properties, etc., to outside modules. And so when they require your module and bring it into theirs, they'll have access to that. And so as we learned from our little Google Groups thing over here, this is how they do that internally to Node, and there's something very similar called require that we use. And so if we keep looking for binding here, and I know that the magic keystroke is a double quote, we can see something really interesting. So it was process.binding. This is all C++ code, but what we can see and start to gather here is that there exists some form of C++ API that allows them to set a method on an object from C++ and have that happen in JavaScript. What they've done here is they've created an object called process. They're creating a property on it called binding, and they're assigning to that property a function defined in C++, which we saw down here. So that's really the heart and the magic of Node. And what we're going to get back to at the very end of this is that Node is an amalgamation of C++ and a number of C++ libraries, all bound together via a common C++ API with a JavaScript API slapped on top, which is generally the only thing you have to interact with, therefore providing you with an extremely simple interface that's hidden away from all this extremely powerful complexity behind the scenes. Okay, so let's just make sure I covered everything here. So yep, we got that guy. Yep. Process.binding. Cool. So there was one more thing that I wanted to look at, and just to get us back to where we were. We started off at fs.js, and we were looking at fsync. And so we use process.binding to get access to fs. So does that mean that there's also an fs C library or C++ library in here? Let's check it out. fs, turns out there's a couple of them, okay? That's interesting. So one's for Windows and one's for Unix. Interesting. I wonder what happens if we come in here and we look for fsync. Turns out there's a bunch of stuff defined in here for fsync. So what we can see there is that there's an API for constructing objects. There's an API for constructing APIs. And this is a C++ API that allows you to leverage V8. And it's the internal workings of V8 that allow you to construct these JavaScript objects in memory. And what they've done is they have sort of married together things that you would normally find on a server, things that are working with file systems in this case, with V8, which traditionally has been used for the DOM and for running and for interpreting JavaScript for the purpose of creating web applications. So we've taken this thing from the web world, and we pulled it out of the browser, and we stuck it to the server, and we started attaching different libraries to give it different capabilities. And it's all done via these C++ libraries. Any questions so far? Cool. All right. Let's keep going. So that in and of itself was a little bit of a deep dive, and I think it merits a little bit of context. And so here is MateoDelNorte's spoken word history of the origins of Node. So it was created by a guy named Ryan Dahl. Ryan is a really interesting guy, and he was not satisfied with web frameworks at the time. He had experimented with developing on and improving both Event Machine, which is a Ruby project, as well as Python's Twisted framework. And both of those are event-oriented, asynchronous web servers, basically. Why would you want an event-oriented, asynchronous web server? Well, it turns out that most web servers are I/O bound. That means that the majority of the time spent serving a request is waiting for a call to come back from the file system, or a call to come back from a database, etc. And in a server like Apache or any number of other thread-based and thread pool-oriented web servers, threads end up stalling and waiting for a request to come back in order to complete that request. And that's why you have a thread pool, so that you can have any number of workers all waiting to, all working on any concurrent requests, and hopefully you have enough workers in your pool to satisfy all the requests that you have coming in, otherwise they're going to queue up. In an event-oriented architecture, it's different. You can field as many questions or as many requests that come in, such that you can kick off the processing that's required, and then you put a little footnote, a little marker on a scheduler to say, go make this file system operation or go make this database operation, and when you're done, here's a little marker with some context and some variables. In our case, it's going to be a JavaScript closure. And when you're done doing all that stuff with Postgres or MongoDB or the file system or whatever, pick this thing up, pass some variables to it, and run it. And what that allows you to do is to run a much larger number of concurrent requests than you could with a thread pool. So that was pretty much the problem that he wanted to solve. And so he, I guess, got the interesting idea that this V8 thing was a potential component for accomplishing this. And we have kind of the spoken word history. The amazing thing about GitHub and open source software is that we can see the actual history. So here we are in the beginning. Let's go take a look. So this is the first number of requests that ever were made in the Node.js repository. And we're going to take a look at a couple of them. The first one is add dependencies. And as you can imagine, it's not really that interesting. I do kind of wonder who this static instance guy is. He does a great job of paying gratitude, even though it's 2016. If anybody wants to possibly hire this guy, the only thing that I would point out is that he does have some blockchain-related stuff in his sources. So I'm not going to say teams should jump on it and reach out to this guy, but I think he's in Canada, and I think he likes blockchain stuff. So anyway, the only thing that is really interesting out of this commit is this libeebb, which happens to be a library that offers up an event loop. So it looks like Ryan wanted to do something with an event loop. All right, cool. Let's look at the next commit. Okay, we've got the add readme and initial code. This looks promising. Let's see what we got. Okay, five change files, 933 additions. Okay, we got a make file. We got some references to some C code. We've got an HTTP request processor. At least he was going to make one or something. And here we go. So we're bringing in V8. Okay. So Ryan wants to bring in V8 and he wants to do something with it. I wonder what else we can find in here. So we've got V8. That's pretty cool. We've got some socket stuff, and he's got server.o. Okay. So he wants to create some sort of a socket server and use V8. That's interesting. Let's see how much HTTP stuff we got. Not a lot of HTTP. I guess he was just like footnoting that one. What else do we got? Do we have loop? We have EV loop. Okay, I'm going to guess that's an event loop. Okay. We have an event default loop. I wonder what this is. So we're going to take a look at this thing, and we're going to do a little search. I wonder what EV default loop is. So it turns out this looks like it's some more low-level stuff. This is some Linux man page stuff. Okay, so libeev, a high-performance, full-featured event loop written in C. Interesting. So this is an event loop that is available to any Linux developer. Let's see, what else does it happen to say about this thing? About libeev. It's an event loop. You register interest in certain events, and it will manage these event sources and provide your program with events. To do this, you have to, it pretty much takes complete control of your process by executing the event loop handler and then communicates via a callback mechanism. This is starting to sound like how Node.js works. You register interest in certain events with event watchers. They're small C structures. You initialize, blah, 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 blah. Okay, So we can start to get the picture that what Ryan wanted to do was take an event loop and make it so that you could start a server, field incoming HTTP requests, and then react to them with code written in JavaScript that is tied together through the V8 engine. And this is actually pretty much the code that he first demoed. And if you go and like search for it, you can find, I think it was like a EU conf or something like that, where he didn't even know if it was going to work, and it ended up working, and people in the crowd were like sending out requests and stuff. So yeah, so from the very beginning, what Ryan wanted to do was create an asynchronous event-oriented server platform that would allow you to write very fast networked applications. So one question, he looked at Event Machine and Ruby and Python's Twisted, and then he chose JavaScript. And everyone hates JavaScript. Why would you choose JavaScript? Well, there's two reasons. One, it turns out that JavaScript itself is event-oriented. And the reason that it is event-oriented is because it has to live in the browser, and it's always run on a single event loop. And so if it runs on an event loop, it's not going to be multi-threaded. Therefore, it has to be asynchronous and event-oriented. Okay, so that kind of works. And the second is, it turns out that all these other platforms already had tons of synchronous libraries. And the likelihood is, if you were to try and build Node.js on top of an existing platform, people are just going to end up taking their asynchronous server and throwing a bunch of synchronous calls in it. And now they're going to be blocking. And then that just threw a bomb in the entire thing that you tried to accomplish, which is a platform for developing completely asynchronous code. Cool. So let's keep rolling. Okay, so we talked about what Node is. We tried to define it in a few different ways. We put on a snorkel. We dove in. How would everybody like to learn about what Node is made of?
Yay!
Yeah.
Here we go. Okay, so this is what actually exists when you run any Node.js code, whether you're just spawning a REPL and executing a console.log hello world, or whether you're running an Express server, or whether you have some distributed system with a bunch of different processes and little microservices. Each one of those processes, regardless of what it is going to look like this. And the way that we talk about code in the Node community is that there's userland. Userland includes any code that runs in your process space that's defined outside of Node core. And so that includes your code, but it also includes anything that you could find on NPM. And this has some interesting ramifications. It means that Node core, which we see in the middle, has a finite number of modules in it, but also preferably a small number of modules. Because we've chosen to keep the API sort of tight and deferred to the community to build anything else, which makes Node easier to maintain. And in the view of a lot of people, ends up making it more usable, and the entire ecosystem gets sort of like more malleable. Things end up sort of organically building over time. And we'll come back with a little proof of that statement later on. But so you have userland. Userland communicates via a Node.js API. That Node.js API consists of both JavaScript and C++, as we saw. Your code most likely will integrate with the JavaScript APIs, but there are C++ APIs if you need to integrate. But for the most part, the point of Node is to write JavaScript, which communicates with Node core JavaScript, which calls V8 APIs, and through that, all these other APIs, libuv, HTTP parser, OpenSSL, etc. And just like we saw when we dove deep into the fs.js file, one of the core mantras of Node tends to also be maintaining very tight naming compatibility with the libraries that it uses. So we were pretty much just seeing POSIX names in the file system API. All they did was just wrap fsync, fstat, etc.
Matt?
Yep.
On this layer diagram, what is the code that most of the other pieces are written in, the APIs and the lower level modules?
It's all C++.
That's what I thought. Okay, I was waiting for you to put in a C++ just to confirm my head. Thank you.
Yes. Yeah, so the only thing that's not C++ in here is half of the Node.js API. And that's the half that typically we'll be developing against.
Got it.
Cool. All right. So here are all those things listed out, and I'm just going to click through these real quickly and just give you sort of a definition of what they are, and then we'll zoom ahead to the next slides, and we'll revisit a few of them in depth. I'm kind of watching the clock here. Just move my thing so I can see it. There we go. Cool. So V8. I think we pretty much all know what V8 is, but it is the open sourced engine that Google ended up buying, actually, from a Scandinavian company. They bought the whole company and brought it in-house. And it pretty much revolutionized the World Wide Web because it allowed us to have Web 2.0 by increasing the speed at which JavaScript applications could run. And it does this through some very fancy C++ code that does just-in-time compilation of your JavaScript, creates C++ types behind the scene that mimic the structure of the objects that you show it. And we'll show in a little bit that there are actually some gotchas about that, that if you want to write extremely performant JS code, there are some things that you should know about how you write your code and how the compiler chain, because there are actually two compilers in V8. There is a interpreting runtime compiler, and then there's an optimizing compiler. And what happens is the first time you run your code, it's just in time compiled by the interpreting runtime compiler. And that compiler is also recording metrics about your code as it runs. And those metrics are being emitted to the optimizing compiler, which listens and is very intelligent and can say, after some time, this code, this function and this code path has run a number of times. Because I know that it runs so many times, I will regard it as a hot function. And I'm now going to write a more optimized version of the bytecode that was originally created by the JIT compiler, by the first JIT compiler, and I'm going to overwrite that. And at that point, your application will actually speed up over time. Now, there are instances where you can do things like deleting a property or adding a property to a object and running it through a function in a way that it hasn't seen before. It will have to create new types, and we'll do a bailout, which will cause it to revert from the bytecode that the optimizing compiler put in, and it'll go back to the original, which will be slightly slower. Anyway, that's just a sneak preview. So that's what V8 is. It allows you to programmatically run JavaScript with C++. libuv. libuv is what ended up replacing libev. We saw that libev was the first thing that Ryan used to create an event loop inside of Node. But it turns out that libev only exists on POSIX systems. It's Linux and some Unix systems. And there are even some Unix systems that don't use libev, but Windows, for instance, does not. So they built an abstraction layer on top. And it turns out that this abstraction layer was really powerful. The event loop was not the only thing that they threw into it. They ended up throwing everything that ended up needing to be implemented on multiple platforms. So file system integration, sockets, DNS, all that kind of stuff. IPC, thread pooling, signaling, all those things that are operating system specific, libuv abstracts those away. And that's the purpose of libuv. So it's kind of a bit of a grab bag, but it's a very powerful C++ library for building evented and event-driven applications. HTTP parser. So we saw on that original commit that Ryan thought that maybe he'd have to make a high-performance HTTP parser because there was that that defines statement. Turns out that he did. He got rid of the EBB parser and wrote his own HTTP parser, which is extremely fast. It doesn't make any syscalls, no allocations, doesn't buffer any data, can be interrupted at any time. It only requires 40 bytes of memory allocated per message stream. So super low level, super fast. OpenSSL. Pretty sure everybody at this company knows what this is. Extremely popular, rock solid C++ encryption libraries. C-Aries. This is basically for asynchronous DNS lookups. zlib, super fast C++ compression library. Node Core, which as we saw, is basically everything here. So Node Core consists of two things, a bunch of JavaScript code, right? So we looked at FS, and FS exposes all the different things for operating on the file system, but also C++ code. So Node Core is sort of the marriage of those. And in general, anytime you're interacting with Node Core, you're going to be looking here at the documentation to figure out what's going on. And then there's this thing which is the binary add-on API. So one of the things that we noticed was that they built Node itself using the applicable parts of the V8 API. And it turns out that there's no reason you can't build additional extensions to the C++ part of Node core in the same way that they attached the JavaScript runtime. And so for much of the life of Node.js, the binary add-on system was really just them saying, hey, here are the functions that you have to call in V8 in order to get your C++ binary add-on to register. And here are things for manipulating functions and objects and running a callback and returning a value, et cetera. And it turns out that just in Node 8.0, they decided to create a ABI, a binary, an application binary interface that sort of abstracts that away. So typically, previously, you would kind of do these types of things where you would have to have an init function and stuff like that. But now they have this NAPI, which makes it that for 8.0 going forward, you'll only have to compile and distribute your binary once. So if you compile against 8.0, it'll still run against 9.0 because the ABI will not change. And that is all done via a Node module that's actually backwards compatible. So if you want to make a new binary add-on that uses C++ to do some really fancy under-the-hood stuff outside of the event loop, you can use this Node add-on API if this ever loads, and you can even target pre-8.0. And I've used this before, so if anybody ever wants to play with this, feel free to ping me. Cool, and so that's pretty much Node. Any questions so far?
I was going to ask if the NAPI or Node add-on API are going to make Babel less necessary or unnecessary.
Make what? I'm sorry?
Babel?
Oh.
The transpiler.
So that's a different thing. So what the add-on API allows you to do is use C libraries and C++ libraries under the hood from JavaScript. So for instance, in the past, I wrote a binary add-on that allowed me to, inside my Node app, create a Python runtime and then use the CPy APIs for spawning a Python runtime in the same process and then interact with it and just marshal objects basically from JavaScript through C++ into Python. What Babel does is allows you to transpile your JavaScript. So it's actually a sort of a pre-runtime step where what you're doing is taking your writing code with a certain syntax, knowing that Node.js cannot natively run that syntax. So what you have to do is run a transpiler step to take your fancy, high-tech, futuristic syntax and convert it into the current, less capable syntax. So for things like async await, which were not implemented in Node until recently, but were implemented in sort of some of the future versions of browsers. What you could do is go ahead and target the modern functionality and language, and then run a Babel step, which transpiles your code so that it will still run the older versions of Node or any other browser runtime. Does that make sense? So they're really two different things.
Yeah, that's helpful.
Okay, cool. And I can answer more questions like that at the end. Cool, so let's dive in a little bit. So I got like 12 minutes, so we're gonna speed up a tiny bit, but we're gonna make this good. Here we go. I have some links in here, and everyone has access to the slides, so you can dive into these a bit more in depth, but we're just gonna kind of breeze through. So how does the V8 engine work? So when you instantiate an object or a type or anything like that in Node.js, behind the scenes, V8 is actually creating C++ types that represent what your object looks like. So in this case, what's going on is he's defined this function here, and this is basically like a factory style function. So he's going to say new point, and it's going to create a new object with X and Y. And so we can see that for P and Q, it's going to end up creating this point type. that has an X and a Y property on it. And so that happens the first time that he instantiates this object, and the second time when this object gets JIT compiled, the internal type lookup system is going to say, I have a type for that. It has the same layout, basically uses some duck typing rules, and so I'm going to use that type, and it's very fast. But if you start doing things like adding, I'm not sure where it's defined in here, but if you do things like if you switch the order of the definition and like you redefine a new point where Y comes before X, or if you add a Z, it's now going to create a new type. And so that's something to keep in mind, that if you're trying to optimize for performance and you have, so basically if you want to optimize for performance, make your objects that pass through a certain function always look the same. Don't change the ordering of properties and don't change the properties themselves. And in fact, make sure that all properties exist. So even if you have to say this.x equals undefined or this.x equals null in order to leave it out, it's better to instantiate them and assign them a null or undefined type. And one extra note, the difference between null and undefined is sort of like a runtime related thing. JSON, when you stringify JSON, if a type is undefined, it won't be serialized to JSON. Things end up going over the wire as a result for requests or message passing. Also won't have them appear. So for memory and speed purposes, you'll want to set those values to undefined, knowing that it won't cause the properties to appear in your database or on the wire or whatever. So yeah, so that's pretty much a high-level thing about how V8 works. You guys can dive into this more later and learn more. V8 also has a multi-generational stop-the-world garbage collector, so you don't have to worry about memory allocation and memory management yourself. So when I say it's multi-generational, basically what it's doing is it's keeping a reference to a pointer that matches up to any of the objects in C and are therefore also exposed to you in your runtime. And it's keeping a tally of their usages. And when those things fall out of scope, those reference counters get decremented. And when it falls down to 0, if the garbage collector does a sweep, it will delete and remove the memory allocated for your object. Goes a little bit further than that. There's a stack and there's a heap, and it's multi-generational. So things that survive more than 2 generations because they're still in use end up going into sort of old land instead of young land. But you guys can dive more into this as well. As I mentioned, there are 2 compilers. Ignition is the interpreting compiler. That's the thing that actually runs your code every time there's a first pass. And then Turbofan is the optimizing compiler. And I'll let you guys dive into these after the talk, since we're kind of running short on time. But the gist of it is that Ignition is a interpreter and compiler, and does just-in-time compilation. It takes your code and converts it into bytecode, similar to how the Solidity EVM takes Solidity and converts it into bytecode. The only additional step here is that it also emits metrics about the runtime behavior of your code as it's executed, and Turbofan is a subscriber to those metrics. Turbofan will listen for those metrics, have them come in, and then it will inject and overwrite optimized bytecode to replace the previously run bytecode if it determines that your code's in a hot path and it's optimizable. And so that's one of the reasons that Node is really, really fast. And it's one of the reasons why V8 itself is just like an awesome piece of software, like really impressive. Okay, libuv. So as we mentioned, libuv is an abstraction on top of libev, but also an abstraction on top of like KQs, and I forget what the signaling events are in Windows, but all those different things. It's used for operations for the file system, TCP, UDP, IPC, thread and thread pooling, signalings, has stuff for synchronization primitives, mutexes, locks, and stuff like that. It also exports an event loop. So that's one of the really important things. If you want to see a super old school but very good introduction on what the libuv event loop is and why you would use it, check out this video. But essentially, an event loop is this. It allows you to run an application such that it takes control of your app completely in a single thread and says, if there are events to process, it will go get the next one. If there's a callback associated with it after it's been executed, execute the callback. And so it's basically a stack of events that are queued up for processing. At any time, if a event is in the queue and the event loop ticks, it will take it. And basically, nothing else will run while your code runs. It will then call a callback. And if that callback spawns asynchronous I/O, it will put it'll put that callback on the stack again and release until the next tick. And so what that means is that I/O can run concurrently. And in fact, everything is concurrent, but your code. So what we'll get to at the very end of this is that Node.js is highly concurrent with no parallelism. And that may sound bad because, hey, with thread pools and stuff, we can be concurrent and have parallelism. Turns out that it can be very difficult working with thread pools. Mutex and locks are very hard to code. And by simplifying things and saying that to the application developer, it seems like it's single-threaded, that actually increases your ability to write performant, good code fast. And when I say fast, I mean quickly. So highly concurrent, no parallelism. This is a really good explanation of exactly what that means. You guys can read it later. We got 5 minutes left, so let's keep rocking. So what is Node made up in depth? The last thing is Node Core. We've talked about it. Node Core is all of this, right? We saw that it's made up of, in the GitHub repository, in the lib folder, a bunch of JS files that define all of these, and then a bunch of source or C++ code in a source directory, which makes all these work and also provides us this little C++ add-on API. And that's one explanation, but this is another great explanation of what is Node. So in the context of Node.js, Node Core refers to the modules and bindings that are compiled into Node.js and generally provide a hook into very understood low-level functionality, just like we saw with fsync in the fs.js and the fs C++ code. Looked like there was a question.
All right.
Okay. And everything else is userland. And so if we remember back to that, that stack that we had that had userland up top, Node Core in the middle, and the operating system on the bottom, this is pretty much the rationale behind why that was decided. Why should you have a tight Node Core, and why should userland be allowed to do everything? When in the past, for things like Ruby on Rails, basically they give you an entire application framework with all sorts of conventions. And Node, sometimes when people come to start their development, they say, well, how do I know how to do anything? Everything is a choice. That was on purpose. They wanted userland to flourish, and they wanted to make sure that they minimized the surface area for Node Core to make sure that it was as best as it could be. So with userland, you get more freedom to iterate. No one's telling you can't build something. You can break conventions. It's easy to publish to NPM, et cetera. And the great thing about less is more is that it gave rise to things that we know about Node now, such as this. There are over 500,000 packages. There are a ridiculous amounts of downloads every single day and every single month. The libraries that can be leveraged within Node vary from async control flow and utility libraries to web servers to things that color the text in your console, things that allow you to write console applications, things that deal with date times, front-end development libraries, IoT, obviously, robotics, all kinds of stuff, right? Like everything that you can imagine that might benefit from having a event-oriented async paradigm, which means typically low memory, low processor requirements. And that in turn, of course, gave rise to other things like this, and this, and this, and this, and this, and we'll see what all those are. For instance, the adoption rate of Node.js over time compared to Ruby on Rails, basically ever since day one, eating its lunch. Things like Webpack, Webpack is something that developers use to build their asset pipelines. They use it to bundle JavaScript, bundle CSS, stuff like that. But when it all comes down to it, it's a command line utility. So the decisions that were made up front about Node.js didn't just end up making Ryan's hope of creating a networked application that fields requests very quickly, but it ended up creating tooling that pretty much every web developer everywhere uses. And of course, we know that that goes into our world with Web3, and Truffle for compiling Solidity contracts and building the distributed web, and Ethereum test RPC for going back to basically networked applications again. So the decisions that they made for keeping Node Core tight ended up having huge ramifications, which caused the ecosystem to have basically a Cambrian explosion, which brings us to today and gives us a little bit of context with why Node is often used in the toolkit of people making distributed applications. It's because, one, it's JavaScript. Two, it's easy to make great tooling. And three, there's a wealth of modules that you can use to leverage to make yourself code faster. So just to reiterate, this is all the stuff that Node's made of. We've gone through each of these. So now we've gone through what is Node.js. It's what Ryan Dahl set out to create, basically an event-driven, asynchronous framework for making very fast network applications. Turns out that it turned into more than that. We took a snorkel and we dove in to see how funny things like doing a console.log on promise and having it say that there's native code in there hinted at the fact that Node.js is really an amalgamation of a bunch of different interesting C++ libraries with a JavaScript interpreter on top offered as the interface for us. And so we can interface with it by just writing JavaScript code. And it's made up of all those different parts that we saw. So what is Node again? Because we haven't written any Node. So what we're going to do is just look at some really, like the simplest Node application that we can use that's going to leverage the file system. This is it. So we'll do const fs equals require fs. That brings in the fs module. Now brings in the JavaScript version of the fs module, which we know because we're crafty and we dove into the source that code will in turn use the fs C++ libraries. And we're going to call fs.write file, and we're going to give it the name of a file and a buffer of some data, and then pass it a callback. So what's happening when we call this? This isn't the best drawing, but it's the best drawing I could find. I kind of wish boxes were moved around a little bit. But basically, our application is this little thing up top, and it's using the V8 runtime in order to execute this file. That's being just in time converted into bytecode, which is executed, which in turn will cause C++ APIs inside of V8, and in this case, also libuv, because we're dealing with the file system. It will also interact with the event loop, and so this particular fs.write file call is going to tell the event loop, I want to make this asynchronous file operation, and when you're done, take this error dash, open brackets, blah, 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 function, and make a note to call that and pass into any arguments if there are any when it comes back. If we're lucky, it'll write a file and there won't be an error, and so it will just pass null into it. And so what we have is the answer to our question that Node, again, is a very simple JavaScript runtime interface that we can develop that looks like it is single-threaded, that hides away the fact that it's actually highly concurrent and actually does have a lot of parallelism behind the scenes. So what's Node again? Node's a crazy concoction of V8 to provide a programming interface upon which can be built Node Core, which is a set of JavaScript libraries provided to us as a single-threaded API, and a bunch of C++ code that wraps together libuv for threads, event signals, etc., HTTP parser for extremely fast memory efficient web connectivity, OpenSSL for security, C-Aries for DNS operations, zlib for compression. And when you really need a hack, there's a binary add-on API that allows you to do crazy under the hood stuff like run multiple threads if you want to, or leverage some other C++ library. And all of this exists so that you get a so that you can very quickly develop performant asynchronous applications. Cool. So that brings us to enlightenment. But there's something about enlightenment that I've always been told, which is that it's not about the destination, it's about the journey. And hopefully what I've accomplished here is given all of you the frame of reference to understand why Node.js was built the way it was built and what it was built to accomplish, such that when you're trying to solve whatever problems you solve in the future, you'll have a better understanding of how to approach them and why the code that you're attempting to use or integrate into your code might have been written the way that it was. And I think that might be more useful than actually finding enlightenment, because there's always more enlightenment to find. So that's the end of my talk. Thanks. Here's a jazz band. Any questions? Muted laughter, maybe. Bye, everybody. Thank you.
But, well, no, people don't have to leave if they have questions.
Oh, yeah.
Everyone's free to leave.
Yeah, any questions? Happy to jump back through different slides or dive into source code or anything.
I put some question into the chat for myself.
I don't have the chat up.
Yeah, it's okay. It's overrun. This is a really higher level, but like, is new syntactical sugar like async await being written in JS or C++?
Mostly C++. So it turns out that async await, what it really is syntactical sugar on top of promises. So I'm pretty sure what's happening is that the V8 runtime is converting those just behind the scenes into promises. That's a good question. It might be a mix, because some of them are being implemented in V8, and so Node will get them for free when it upgrades its version of V8 just by upgrading its dependency. And some of those things are added on top. So it's sort of, it depends. I don't know the answer to that one, but I think the example for promises is that it's in V8, or for async await and promises.
Mm-hmm. And this is a super specific question, but it's easier. Yeah.
Go ahead.
You mentioned like colorful like console.logging output, and not really that, but like I find that stack traces in Node.js kind of suck. Is there anything that makes that suck less?
Yeah. So the reason that stack traces can suck is that well, basically it's asynchronous. So to the runtime, it doesn't necessarily know what caused your code to make a call to Postgres or MongoDB or whatever. It just knows somebody's got the... Too bad you can't mute people on here.
I can.
Oh, yeah. You want to mute his? There's no name on it. It is Kirk.
Okay. I'm on it.
Cool. So... the reason so I think what's happening there and what you're observing is that your stack trace effectively starts with the callback to whatever your last call was. And if there are multiple places within your code that might have called that library, then you don't necessarily know how you got there. And that's sort of just a symptom of event-oriented systems. And frankly, it's a symptom of event-oriented systems regardless of whether they're single process or multi-process. You'd have this same problem if you had a distributed system with 5 different single processes and you don't know which one called the one before. You'd only have a stack trace within that one, right? So it's really an event-oriented thing. And the solution is either fancy collection of metrics that allows you to stitch together stack traces that happened before and after you went async, or logging. And The logging one is used most often. So you can do things like log correlation IDs. So whenever I build systems, even if I do message passing between systems, I tend to have like a correlation ID on a message that comes like into a web server, which is then sent as a message over to a bunch of backend processes, which then emit stuff, and you have like this dance that ensues. You pass the correlation ID along, you have unified logging, and then you can trace things through your logs. So that's one thing that can really help you. And the second is the instrumentation part. And this is something that I've complained about to the Node steering committee for some time, to be honest, that we need better, basically debugging and instrumentation within Node itself for this purpose. And luckily, Microsoft is actually working on some really cool stuff. So Microsoft actually has their own version of a JavaScript runtime engine. It's called Chakra Core. And they have builds of Node.js which run on Chakra Core instead of V8. And I've been a part of some like user testing where they have shown me versions of their Node where you can do really cool things like attach to a core dump from a production. Literally, so if a production system detects an error, it will email you a core dump, and then you can attach to that in VS Code, and you can walk backwards, and you can even pass previous to where you went async. So there's some really cool stuff being developed for that. I don't know what their timeline is. They showed me like half running code and half mockups. So it's possible that that kind of stuff could be released soon.
Cool.
Are Chakra
cool. Sorry, go ahead.
Sorry.
Ava?
Are Chakra and SpiderMonkey, like, are they a little different? Are they a little, like, any issues?
I mean, they're all a little bit different, right? So SpiderMonkey is what runs Mozilla, V8 is what runs Chrome, and Chakra Core, I'm pretty sure, just runs Edge. You know, there's websites online where you can kind of look at like the comparison of like ECMA, you know, defined features that have been implemented in each of them. So they're all totally different code bases, but they're all trying to implement a lot of the same features. They have different priorities for different features based on their organization. Microsoft's development is mostly around maintaining IE market share, but more importantly, they run Chakra Core inside of Azure because it gives them a better sort of like performance signature on their cloud, and they're eking out, you know, some additional performance and also offering additional features. So it's possible that this like additional instrumentation and like debugging capability may only be available on Azure, but I told them that they shouldn't do that. We'll see what they do. But yeah, they're all a little bit different because they're separate code bases, but they're all trying to accomplish similar things for the browser. But they're all used in places outside the browser as well, in Node, in Azure, etc. Does that answer the question?
Yes, thank you.
Cool. Anybody else? Cool. Well, I am MateoDelNorte on Slack and on Twitter and on GitHub and pretty much everywhere else. Feel free to hit me up any way possible. Always happy to chat about Node stuff. Hopefully this gave everyone a really good historical, in-depth perspective of why Node is, what Node is, and how you can begin to use it to rule the world. All right, everybody, thank you.
That was awesome. Thanks, Matt.
Bye-bye.
Thanks, Matt.